Hi, this is Adrian from Live to Learn Academy, and today we're going to be going over lesson 4.4, rates of change in polynomial functions. Now for today's lesson, guys, I'm going to be going through a bunch of word problems. We've taught AROC, we've taught IROC back in chapter 2. So this chapter, it's really just expounding on that concept, but doing it for polynomial functions, especially these word problems. So if you're somebody who needs tutoring for advanced functions, feel free to click the link in our description. You'll get in contact with our team, and we'd love to help you ace this course. Now, I know some of you guys are not subscribed to the channel. Feel free to subscribe for more lessons like this. If you guys have questions, drop it in the comments, and feel free to share this video to any of your classmates who are also taking the course with you. But without further ado, let's get straight into it. So let's look at this question, okay? A construction worker drops a bolt while working on a high-rise building 320 meters above the ground. After t seconds, the bolt's height above the ground is s meters. So the equation that they gave us is this. And they also gave us a range. So this is what's happening. The equation of the bolt dropping off the building looks like this, but it's only from 0 to 8 seconds. So the question here is saying, find the average velocity for the interval 3 to 8 seconds. So look, average velocity from 3 to 8 seconds. Notice how this question, it gives you 2 points. Therefore, we should know right away this is an AROC question. But if you look at part B, it says find the bolt's velocity at 2 seconds. So it doesn't say average velocity. It says the bolt's actual velocity at 2 seconds. So, and it only gives us one time. So we know this question is going to be IROC. Okay, so the first thing I want you guys to recognize is AROC always has to deal with 2 points. IROC always has to deal with 1 point. So let's first start off with part A. We're going to say the average velocity, or the AROC, is going to be s at 8 minus s at 3 over 8 minus 3. Okay, so that's how we know the average velocity AROC equation is going to look like. But now we actually got to find each of these terms. So let's do them separately over here. So s at 8 is going to be 320 minus 5 times 8 squared. So let's do that in our calculator. And we end up with 0. Just double check. Yep. Cool. And let's do s at 3. So that's 320 minus 5 times 3 squared. Which is 275. So if we take those numbers and we plug it in here, we're going to get 0 minus 275 all over 8 minus 3, which is 5. And we get negative 55 meters per second. So that's what the average velocity is. And remember, velocity, right, is in meters per second, right? That's why I knew that the units would be that. Okay, let's look at part B. Part B is saying find the bolt's instantaneous velocity. So the velocity at t equals 2. So remember, when we have instantaneous velocity, the way we're going to get that is we're actually going to use the AROC to approximate the instantaneous velocity. So that means we're going to use the centered interval method. Okay, centered interval method. I don't even know if I spelled interval right, but you guys get the point. So the centered interval method is basically going to say the instantaneous velocity, otherwise known as the IROC, is going to be s at 2.1 minus s at 1.9 over 2.1 minus 1.9. So remember, with the centered interval method, we're taking a point that's to the right of 2 and a point to the left of 2. But we want those 2 points to be really, really close to 2 when it comes to approximating the IROC, right? So let's do that. We're going to do these separately. So s at 2.1 is going to be 320 minus 5 times whoops, not 8. This is going to be 2.1 squared. So we got 2.1 squared times 5. So you end up here with 297.95. And then we're going to do s at 1.9, which is 320 minus 5 times 1.9 squared. So you end up with 301.95. So now we can plug these both back into our equation. So we have 297.95 minus 301.95 all over 0.2. And when we finish out that equation, we'll actually get negative 20. And remember, it's also going to be in meters per second. Cool. So this is pretty straightforward. Average velocity, we're using the AROC because they give us 2 points, so it's really easy. S at 8 minus S at 3 over 8 minus 3. Find it out. And then centered interval method for approximating the IROC. So we need a point close to 2 on the right side and the left side. So 2.1 and 1.9. Okay, moving on. Let's go to the next question. Very, very similar type of question. It says the height in meters of a toy rocket above the ground can be modeled by the function this, h at t is equal to negative 5t squared plus 50t, where t represents time in seconds. Cool. Okay, use average speed to approximate the instantaneous speed at t equals 4. So what is this? We're talking, this one is going to be IROC. And then if you look at the second question, in fact, it's the same thing, but it's just at a different time. So it's still going to be IROC. And then for the third question, it tells us what's the average speed over the interval from 0 to 10. Remember, it gave us 2 points, so it's going to be AROC. So let's do this out. We're also going to use the centered interval method for part A. So we're going to have h at 4.1 minus h at 3.9 over 4.1 minus 3.9 because we're approximating it at 4. So if we actually do that out, h at 4.1 is equal to 4.1. We'll actually write out the equation, negative 5, 4.1 squared plus 50 times 4.1. So you end up with 120.95. And then we're going to do the same thing for the 3.9. By this time, guys, you guys should already have this down packed. It's very, very similar to the other question we just did, but we're just doing it twice. So what we're going to end up with is 120.95 minus 118.95 over 0.2. And you end up with 10. And remember, because we're dealing with speed, we are in meters per second as well. Cool. Let's look at part B. So part B, we're just doing the same thing, but we're doing it with 10 now. So here we're going to take 10.1 and 9.9. And this is why I love the centered interval method, because you just take it on the right and the left side of it. So h at 10.1 is equal to negative 5 times 10.1 squared plus 50 times 10.1. So you end up with negative 5.05. And then we got to do it for 9.9 as well. So we have negative 5 times 9.9 squared plus 50 times 9.9. And you end up with 4.95. Cool. Now, when you have this, let me just double check my math for a sec. (9.9 squared times negative 5 plus 50 times 9.9). Yep. Okay, cool. So now what we're going to do is plug it in. And for the center interval method, notice how the denominator is always going to be 0.2, right? Because we're just taking 0.1 on the right and 0.1 on the left. And here what we get is negative 50 meters per second for part B. And then part C, I'll actually move the third question down a bit. Part C, we're doing the AROC. So remember, part C, it gave us these 2 points, 0 and 10. So now we're going to do the AROC at 10. So we're going to have h at 10 minus h at 0 over 10 minus 0. So let's do h at 10, which is negative 5, 10 squared minus 50 times 10. So this becomes negative 1,000. And we have h at 0, which is 0. So we plug this in, we get negative 1,000 minus 0 all over 10. And then negative 1,000 divided by 10 is negative 100 meters per second. Cool. And that's our answer. So the first 2 questions, guys, very, very straightforward. You know, we're just doing AROC and IROC, getting the 2 points for AROC. IROC, you're just doing it with 1 point, but you're using the centered interval method. So now I want to get you guys to understand this type of question. So this is a thinking type of problem. And the reason why it's a thinking type of problem is you actually got to think, right? So let's look at how this problem works out. It says, consider the function f at x is x cubed minus 4x. So first question, it says, estimate the slope of the tangent line at 1. So here we know we're going to be using IROC. So let's do the IROC first. So we're going to go f at 1.1 minus f at 0.9 over 1.1 minus 0.9. So let's do that out first. We have f at 1.1, which is 1.1 cubed minus 4 times 1.1. Negative 3.069. And then we got f at 0.9, which is 0.9 cubed minus 4 times 0.9. Okay, so let's plug those in. Negative 3.069 minus negative 2.871 all over 0.2. So notice how the minus and the minus will actually give us a plus. So let's put that in our calculator. Plus 2.871 divided by 0.2, and we end up with negative 0.99. Negative 0.99. And this isn't meters per second because we're not dealing with velocity. So I'm actually just going to round this, I'm just going to approximate it to -1. Okay? So what this means is that if we think about our function, okay? If we think about our function is going to look something like that, right? Because it's a cubic function. But at the point 1, right? At 1, we're trying to find that tangent line. So this tangent line is going to look like, something like this. Or let's say 1 was here. It would look something like this. Okay? So all we found right now was the slope of this line. So the slope of this line is actually -1. The slope of the tangent line at 1 is -1. Okay? So remember, this is the slope of the tangent. Okay. Now, this leads us into part B. So it says, using the slope and the point of tangency, find an equation of the tangent line. So all we found was the slope of the tangent. So if we want to find the equation of this tangent, we know it's going to be y equals mx plus b, right? Because it's a line and it's going to be a linear function. So if we have y equals mx, so this is for part B, if we have y equals mx plus b, and we know the slope is actually -1, because that's what we found, in order for us to solve this equation, we actually need to find an x and a y value, so a point that we can plug in so that we can solve for b. Okay, so the question is how do we get that point? So the way we get that point is we're actually going to use this point right here. So this point right here is f at 1 equals some number, right? We want to find the y value of this point, because then that will give us that point. So what we're going to do is we're actually going to find f at 1 by using the original equation. So what we're going to say is f at 1 is equal to, this equation. But we're actually going to plug in the 1. So 1 cubed minus 4 times 1. F at 1 is equal to 1 minus 4, which is -3. So now we know that this point is 1, -3. And we're going to use that to plug these points in as y and x so that we can solve for b. So let's do that, because this is going to help us determine the equation of the tangent. We need that b value. So let's say we do -3 is equal to -1 times 1 plus b. -3 is equal to -1 plus b. -2 is equal to b. Okay, so we found the b value. So now the equation of the tangent is going to be -1 x minus 2. And honestly, you don't even have to put the -1x. You can just put -x minus 2. Okay, so this is a thinking problem. They're gonna test your ability to really understand what's going on. So we need to find the point. This is where that point is going to be. The point is going to be from the actual thing that they told us in the question. They said at x equals 1. So if I plug in 1 into here, I'll actually get the point. And the only reason I need the point is because I need that point so that I can solve y equals mx plus b. Because if I don't have the b value in the linear equation, then I don't actually have the equation, right? So that's how you guys do part B. So that's a little tricky one. And let's go to part C. Part C says, the tangent line intersects the original graph one more time, but where? Graph the original function and the tangent line to illustrate this. Okay, cool. So look at this tangent line. Now we know this tangent line is -x minus 2, right? But if you see, this tangent line also intersects at another point. Another point of intersection. So the question now is asking us, how do we find that point of intersection? Well, I'm going to show you. The way you find the point of intersection is you equate the original function, which is x cubed minus 4x, and you equate it to the linear function of the line. So this is the original function, and we're equating it to the equation of the tangent. Okay, so you're taking the original function, you're equating it to the equation of the tangent, and then we're going to solve. So now, how do we solve this? Well, we're going to have to bring everything to one side. So I'll say x cubed minus 3x plus 2 equals 0. And then from here, we're actually going to have to use, we're going to have to factor this equation. So how do we factor this equation is the next part. So the way we're going to factor this equation is we're going to have to do a different kind of method. We're going to have to do the guess and check method to see how we can do it. And then we have to do the synthetic division and, you know, factoring those cubic polynomials. So this thing, right, in order to factor this, we have to use factor theorem plus synthetic division to get the factors. Okay? So what I'm going to do is I'm going to guess and check a factor first, right? Remember, we got to guess and check a factor. -2, -1, 0, 1, 2 is what we're going to guess and check. So if I say f at 1, I'll get 1 cubed minus 3 times 1 plus 2 equals 0. I want to see if it equals 0. So here we get -2 plus 2 equals 0, so 0 equals 0. Therefore, we know, x minus 1 is a factor. Now that we know it's a factor, what we're going to do is we're going to take that 1 and we're going to do the synthetic division with the original function. So it's going to be 1, 0, -3, and 2. Mind you, remember, the reason we have that 0 is because we don't have this x squared term. We don't have that x squared term. That's why I have to put that 0 in there as a placeholder. Okay, so now what we're going to do is we're going to solve for the synthetic division. So 1 times 1, and remember we're adding as we go down. 1, -3 plus 1 is -2, -2, 0 remainder. So then this right here is our quadratic, which is x squared plus x minus 2. So now if I take this whole function, I'm going to have x minus 1, x squared plus x minus 2 equals 0. And then I'm going to see if I could factor even a little deeper. So x minus 1. Here I can go x minus 1 and x plus 2, because I factored this guy into those two. And then I can rewrite the equation, finally rewrite the equation as x minus 1 squared and x plus 2 equals 0. So therefore, my roots are x equals 1 and x equals -2. Now look what that tells us. What does that tell us? That tells us that, oh, my roots are x equals 1 and x equals -2. Therefore, if those are my roots, I already know I have this point at x equals 1, which is 1, -3. Right? Notice how that point right here that we had is 1, -3. (1, -3). Damn. So yeah, that'll be actually 1, -3. But this point right here is going to be at -2. Now obviously this is a sketch, so it may not be to scale exactly. But what we need to know is that that's where the points are going to be. So we know that next point is going to be at -2. So what do? We take -2, we plug it into the original equation to get that exact point. So if we take this -2 and we're plugging it into the original equation, which is x cubed minus 4x. So f at -2 is equal to -2 cubed minus 4 times -2. So here you're going to get -8 plus 8, which is 0. Therefore, the other point that it intersects at is here. This is the other POI. So the reason I'm showing you guys this is because when you actually graph this, now we have a lot more information to graph it. So at 1 and -3, that's where we're going to have this point. And then we're also going to have another point at -2 and 0, which is this point. And we know that the graph itself is going to look like this. It's going to be a cubic function. It's going to be a cubic function like that. So this function is going to be y equals x cubed minus 4x. And we also know that the point of the tangent at this point, is going to go through both of these points, right? And we know this equation is -x minus 2. Do you see that? So you see how there's 2 point of intersections. There's a point of intersection here, and there's a point of intersection here. So this, guys, is a really, really good question. I really recommend, you guys review this last question, this thinking question, problem 16, because I think this can come on a test, and a lot of people will get stumped on this. So I hope this video, helped you guys out. If you found this video helpful, drop a like, subscribe to the channel, and feel free to follow for more videos like this. I'd love to hear your questions. If you need tutoring, feel free to reach out to our team. We'd love to get in touch with you. But without further ado, I'll see you guys in the next video.